Tesla appears to be preparing one of those moves that not only changes the game, but turns the tables entirely. And the centerpiece of this move is a new battery that, instead of lithium, relies entirely on aluminum. But it's not just about swapping one metal for another. What's at stake is a complete transformation in how electric cars deal with heat. That silent villain that robs range, ages cells, and, worse still, puts entire vehicles at risk of fire. The aluminum-ion battery promises a thermal and structural revolution with the potential to reshape everything we know about energy efficiency in EVs. And the most intriguing thing? This is no longer just a dream. The launch is scheduled for 2026. The basis of this revolution lies in the materials. Instead of using graphite-based anodes and flammable electrolytes like conventional lithium batteries, the new architecture combines a metallic aluminum anode with a carbonaceous cathode and an ionic chloroaluminate electrolyte. This exotic mixture may seem complicated at first glance, but it offers breathtaking ionic conductivity, even at room temperature. And do you know what this means? The battery can operate at high power without heating up like an electric kettle. By cooling the process from the inside out, it escapes that classic trap. More energy, more heat, more wear. If you've ever tried to quickly charge an electric car on a hot day, you know that heat becomes enemy number one. It degrades components, strains the cooling system, and, ultimately, forces the car to reduce power to avoid self-destruction. Interestingly, much of this heat comes not from the outside, but from within the battery itself, from the internal electrical resistance and chemical reactions that accelerate as the temperature rises. The aluminum battery breaks this vicious cycle by eliminating the main risk factor, the electrolyte itself, which is now virtually immune to evaporation and fire. In other words, the problem is deactivated at the source. And it doesn't stop there. The electrochemical behavior of this new system is much more stable during rapid charge and discharge cycles. This means that even when the battery is subjected to extreme demands, as occurs during hard acceleration or trips with repeated recharges, the internal structure doesn't deform, doesn't create dangerous metallic deposits, and doesn't suffer accelerated wear. The stability of aluminum during the formation of ion layers is one of the advantages of this new design, allowing high-speed recharges without thermal collapse. In practice, it's as if the car doesn't feel the jolt. All of this leads to a silent but brutal change in battery life. Today, every time an electric car overheats, a little bit of its range is lost forever. This wear and tear is cumulative, and over time, it becomes a headache for the owner, and an argument against the mass adoption of EVs. With the aluminum battery, the promise is that wear and tear will be so slow that it will barely be noticeable over the years. A car that maintains its stable range for longer also maintains its value and trust, especially among those still skeptical of the longevity of electric vehicles. Another interesting point is reliability in extreme situations. While lithium batteries still rely on complex thermal monitoring systems, aluminum batteries are inherently safer. Even when exposed to abuse such as overcharging, impacts, or exposure to external heat, they are less likely to ignite. This doesn't mean accidents will stop happening, but the risk of a catastrophic thermal event, the technical term for a battery fire, will be drastically reduced. And this, of course, changes everything in the vehicle safety game. It's also worth noting that this revolution isn't just technical, it has a direct impact on the driver experience. Cars with cooler, more stable batteries don't require repairs as often, don't trigger overheating warnings on the dashboard, and don't lose performance over time. This means fewer hassles, fewer costs, and more confidence to hit the road in any weather. Instead of driving in fear of overheating, drivers simply drive. No more heat paranoia, no more mental calculations with every quick recharge. Despite the enthusiasm surrounding the aluminum-ion battery, turning this promise into a commercial product will require more than good ideas and impressive technical graphics. The first serious challenge begins with the electrolyte. Chloroaluminate ionic liquid, while highly conductive and non-flammable, is sensitive to humidity. It is hygroscopic, meaning it easily absorbs water from the environment, and this can compromise its chemical stability. In a factory where everything must operate with millimeter precision, this characteristic significantly complicates the assembly line. It's not just a matter of sealing well, it's a matter of controlling the entire surrounding environment. And this sensitivity demands very specific measures. The cells must be assembled in humidity-controlled environments, almost like the clean rooms of the semiconductor industry. The parts that come into contact with the electrolyte, gaskets, current collectors, sealants, even the cell casings themselves, must be chemically compatible for years, without corrosion or degradation. This requires new materials, new suppliers, and a complete rethinking of the production chain. Tesla can't simply adapt its current lithium-ion battery factories. It will have to create a parallel production structure, tailored to this new chemistry. And this brings us to the second hurdle: scale. It's one thing to assemble a few batteries in a laboratory, in small quantities, with extreme care and direct supervision. It's quite another to do so in hundreds of thousands of units per year, with the industrial efficiency Tesla strives for. Producing at scale without compromising quality or safety is the ultimate challenge for any revolutionary innovation. To succeed, the aluminum battery must maintain its thermal and chemical advantages even under the pressure of mass production, where every second, every cent, and every gram counts. Furthermore, there's the issue of cost. Even though aluminum is abundant and cheap, the other elements of the system, such as the ionic electrolyte and highly controlled manufacturing processes, still have a high cost per unit produced. And for this battery to truly take off, it needs to be competitive not only technically, but also financially. No one will want to pay double just for a battery that doesn't heat up, even if it promises to last longer. The cost-benefit equation must be objectively balanced for the consumer, and this requires a lot of optimization, automation, and innovation behind the scenes of production. Another critical point is maintenance. A system so sensitive to moisture and corrosion requires different repair and diagnostic protocols than current ones. Workshops and service centers will need to be trained to handle a completely new battery, which cannot be opened or manipulated like lithium-ion batteries. This raises concerns about the time and cost of potential repairs and puts pressure on Tesla to develop modular solutions that allow for quick component replacement without compromising the cell's seal or chemical integrity. Even so, if these obstacles are overcome, and Tesla has a track record of making the impossible possible, the impact will be enormous. Imagine a battery that lasts longer, heats less, is safer, and can even be mass-produced with abundant raw materials. This completely changes consumer perception of electric vehicles. The fear of accelerated wear, fires, or long waits at the repair shop disappears. And in their place emerges a reliable, robust, and easy-to-maintain car, essential for those seeking practicality in their daily lives. This practicality, in fact, will be one of the new technology's main selling points. For many drivers, electric cars still seem too complex, too technical. The aluminum battery can simplify this image, offering a more predictable, more stable experience, almost invisible in terms of concerns. Charging, driving, maintenance, everything can become more fluid. But to achieve this, Tesla will need to prove that this battery works not only in the lab, but also on the street, in the heat of Texas, the cold of Chicago, on the hills of San Francisco. It is the real proof that will decide the future of this revolution. And this trial by fire won't just happen inside the factories. Tesla will also have to convince the financial market, regulators, insurers, and, most importantly, consumers that this new technology is reliable, scalable, and advantageous. It's not enough to be innovative. It needs to perform in all aspects: technical, logistical, and economic, with the same reliability as lithium batteries do today. Only then will this thermal and structural revolution move beyond being a promising experiment and become the new industry standard. If there's one thing that discourages any electric car driver, it's the line at the charging station. Arriving with your battery nearly dead and finding all the chargers occupied, while each car takes 20 or 30 minutes to leave, is the perfect recipe for frustration. But the new aluminum-ion battery could change that once and for all. With its ability to support ultra-fast charging without overheating, it can transform a Model 2's recharge time into something as quick as grabbing a cup of coffee. Literally, from 10% to 80% in just 15 minutes. And most impressively, without needing a special charger, using the same 250 kWh available today. This performance leap is due to the fact that the aluminum battery can maintain high charging rates until the final moments of the session, without the dreaded power dip that plagues conventional lithium-ion packs. With lithium-ion, charging goes well initially, but needs to slow down as the battery fills, due to heat and the risk of dangerous metal plaque formation. With aluminum, thermal stability and ionic diffusion kinetics allow it to maintain constant power for longer. This shortens the session and avoids wasted time in the final stages of charging. Now, imagine the impact this will have on charging stations. With shorter sessions, the number of cars served per hour practically doubles. A single charger that currently serves 2 or 3 vehicles per hour can now serve 4 or 5, depending on demand. This reduces wait times, shortens lines, and makes life easier not only for those who already drive an EV, but especially for those still wary of relying on the public grid. It's a subtle change in everyday life, but a dramatic one for the perception of convenience. And this practicality translates into freedom. With shorter recharge times, drivers can plan long-distance trips, just as they would with a gasoline-powered car. There's no need to add safety buffers to their itinerary, or avoid certain routes for fear of waiting hours on the road. A quick stop at a mall, supermarket, or food court is all it takes. And voila, range restored. This transforms the electric car from a planned experience to something much more spontaneous. And freedom, let's face it, has always been what we expect from a car. Those who will celebrate this change the most are urban drivers who don't have a charger at home. These are people who rely exclusively on the public grid or chargers at work. With quick and predictable weekly recharges, it's easier to keep the car full without disrupting your routine. A trip to the grocery store, a coffee at the mall, or a quick visit to the gas station are enough to maintain optimal range. This reduces range anxiety and makes electric cars viable even for those who live in apartments without private garages. And as a consequence, there's a multiplier effect. Higher turnover at charging stations means the current infrastructure lasts longer before needing expansion. Queues shrink not because more chargers are built, but because existing chargers become free faster. This reduces the cost of network expansion, helps operators offer better rates, and makes the entire ecosystem more efficient. When the usage time at each station decreases, the queue simply disappears. Of course, there will still be peaks in usage during holidays and rush hour, but even then, the difference will be felt. A system where the average time per car drops from 25 to 15 or even 12 minutes completely changes the pace of service. Flow improves, frustration decreases, and the user experience increasingly approaches what combustion engine drivers are accustomed to, or rather, surpasses it. And when user comfort is combined with insurance savings and cell durability, the package becomes virtually unbeatable. With this battery, Tesla isn't just creating a new type of cell, it's eliminating several of the most common arguments against electric cars. And all this with technology that will begin real-world testing as early as 2026, directly from the production lines of the new Gigafactory in Texas. While many people still associate a car's resale value with its paint color or number of previous owners, the story is quite different in the world of electric vehicles. What really dictates price in the used car market is the health of the battery. If it's degraded, the car depreciates quickly, even with few miles on the clock. And this is where another powerful advantage of the aluminum-ion battery comes into play: its impressive resistance to aging. It promises to maintain stable capacity for much longer, which could completely redefine the EV resale market, especially for affordable models like the Model 2. Today, anyone considering buying a used Tesla almost always wonders, how much range does it have left? This uncertainty weighs not only on the buyer, but also on dealers, banks, and even financing programs. If the car is expected to lose 30% of its battery capacity in a few years, its resale value plummets. But if the data shows that degradation is minimal, everything changes. The Model 2, for example, can go from an expected 55% retention rate to something close to 65% of its value after 7 years. It may not seem like much, but it represents thousands of dollars in appreciation. And this gain isn't just on paper. It has a direct impact on financing conditions. With a more stable and reliable battery, banks feel more confident offering longer terms, lower interest rates, and even approving more credit for middle-income groups. This is because the car becomes a more solid asset, that is, more predictable in terms of future value. And since the Model 2 is designed specifically to serve this audience more sensitive to monthly costs, this change could be the boost needed for a massive sales explosion. This stability also fuels the certified car market, such as pre-owned programs with warranties. If the aluminum-ion battery retains most of its range after 5, 6, or 7 years, it becomes much easier for dealerships and online platforms to sell these cars with a quality seal and extended warranties. This attracts buyers who want to save money, but are still wary of buying an electric pineapple. Ultimately, more trust generates more liquidity, and more liquidity fuels the entire ecosystem. Another group that benefits are fleets. Companies that renew their vehicles every 3 to 5 years need predictability in resale value. If the car retains its value better, losses on trade-ins are smaller, balance sheets close with a larger margin, and purchasing decisions become easier. This increases the Model 2's chances of becoming the darling of delivery companies, rental agencies, and even public services, such as patrol cars or vehicles for institutional use. It's a self-sustaining value chain, and one that directly depends on battery health. In the hottest U.S. states such as Texas, Florida, Arizona, and Nevada, this benefit is even more evident. Heat accelerates the degradation of lithium batteries, which affects cars in their first few years of use. But with the new battery operating cooler, even in scorching environments, the thermal impact is drastically reduced. This ensures that the car's performance remains stable, without any range shocks or loss of power during acceleration. A Model 2 that doesn't lose power in the Texas summer is a selling point that speaks for itself. Another detail that cannot be ignored is the environmental and logistical impact. Aluminum is abundant, recyclable, and widely available in the United States. This means less dependence on international supply chains, less impact from trade wars, and more control over production costs. With factories like the Texas Gigafactory operating with a focus on this new type of battery, Tesla can ensure local production, shorter delivery times, and more predictable pricing, crucial to keeping the car's value competitive for many years to come. This combination of durability, predictability, and domestic production creates a solid foundation for Tesla's continued growth